Hello everyone, this is Dr. B. Mahalakshmi, Assistant Professor, Department of Artificial Intelligence and Data Science. So today we are going to see about the lecture video in the concepts of digital and mobile forensics. Subject code is CCS 343. Subject code is CCS 343. So here in this digital and mobile forensics, the fourth unit will be iOS forensics. So under this iOS forensics, we are going to see about the concepts of mobile hardware and operating system. What is iOS fundamentals? It's an important concept. Under this iOS fundamentals only we are going to see architecture and that file system, and we have the security, what are the security inbuilt concepts we have, and then iOS everything, and after jailbreaking, and it's one of the tool iOS forensics tools, and hardware iPhone security, iOS forensics, what are the procedures and processes and tools. Oxygen forensics is one of the familiar iOS forensics tool. We will use for this iOS as well as Android. So these concepts only we are going to see here in the fourth unit. And finally we have the iOS forensics tools like mobile edit and iCloud. So here we are going to see what is iOS. We have to know what is mobile hardware and operating system. So in desktop, computers components are separated. In mobile phone, due to size limitation, everything is packed into tiny silicon pieces called as SoC. For a forensic investigator, understanding the SoC model tell you exactly how data flow inside that specific model and how difficult it might be at tap physically into the memory components. So here that it's a simple examples they gave. What is system on a chip? It's nothing but SoC. That's what I told you now. It's a computer in the sense components will be separated, but here in the mobile it will be in the single components. So that SoC, that for a forensics investigator understand what is SoC model and tell you exactly how data flow inside that specific models and how difficult it might be to tap physically into the memory components. And here we are seeing about what is central processing unit, and here digital processing the signal processor. So CPU in a mobile devices is integrated with the SoC itself. So and then here that silicon pieces called as what? SoC. Okay, and it's essential for executing the instruction and performing the calculation. Here the digital signal processor is convert the digital signal into the analog for the communication. So it handle the complex mathematical operation for signal compressions as well as filtering. Okay, so next to here we are going to see about antennas and transmission basics. So what is antennas? Antennas is a vessel for the cellular communications to radiate and receive the electromagnetic waves. So it contains two, that is omnidirectionals and bidirectionals. So simple example, that explanation is phones rely on antennas to talk to the cell towers. Okay, and omnidirectional antennas send signals everywhere, so you do not lose connection when turning around, whereas directional antennas focus power towards a single target to send data further away with less interference. So here we have the two types of this antenna we saw here, that is omnidirectional, radiates electromagnetic waves in all the direction. It radiates, the directional means is that radiates electromagnetic waves in a specific direction. Is all is an omni, and then direction is a specific. And then dipole antennas. This dipole antenna is nothing but this is the classic type of antenna design. Think of it like two metal rod. That's what that's a diagram I shown, that by the dipole antenna. So here two metal rods pointing away from each other. The size of the antenna must structurally match the math of the radio frequency wavelength it's trying to catch. So if the device changes the size, it affects how cleanly the signal is captured. So this antenna is one of the components. Okay, so before we are going to see what is iOS and what is Android, these are the basic concepts we have in the mobile operating systems. And this antenna characteristics, what is that is a radiation pattern, the directivity, gain, efficiency. So these properties dedicate how effectively the phone maintains its cell signals. High directivity and gain mean cleaner connections to the distance towers. So poor structural efficiency means your phone turns electrical battery powers into wasted heat instead of the stable signal transmission, creating the battery drain. So here there's an antenna characteristics. These are playing a very important role, vital role, right, for the signal processing, radiation pattern, directivity, gain, and efficiency. Okay. So and here the antenna region is nothing but wave propagation speeds. So break down the spaces around the antenna into three zones, that is reactive near field, radiating near field, and far field. So here that is a reactive near field, the zone closest to the antenna where magnetic induction dominates. That near field is the middle boundary where waves start cleaning up and spreading up. Okay, and here the third one is here the distance zone where the radiated wave power predictively drops relative to the distance. So these are diagrams I shown about the parameters in that antennas. So now we are going to see what is the importance of the forensics examiner. So here we should understanding the limits of the tool, and here we have the tools that in this concept here we have the tools like Celebrate, Mobile Edit, Oxygen, etc. Oxygen forensics and the limitation. So the forensic examiner must understand all the aspects of the device being examined, including the hardware and software oriented. So it's playing an important role that for mobile and operating components is a crucial role for accurate and thorough forensic analysis. So next one is what? SIM card. So here that in the SIM card, here it's an abbreviation of here subscriber identification model, also known as the user identification card or smart card. So in this SIM card, so here this is also play the vital role in this Android forensics. So store user related data, network related data, and the relevant business code, and here user information such as the phone number, book, authentication uses. So this here the display and the what is abbreviations of the SIM I shown. And next one is SIM card internal structures. How it will be is a chip card with that microprocessor, and it is composed of 5 models. In that we have a CPU, the read-only memory, random access memory, and then erasable, that is electrically erasable, programmable read-only memory, and I/O circuits. So and each model corresponds to the function microprocessors, and working the memory of the 6 to 16K bit, and data memory will be this 128 to 258K bit, and the serial communications unit. These 5 models are sealed in a copper interface of the SIM card in the same way as the ordinary IC card, that integrated chip card. So here this is the fact it is a microprocessor. So next is the development of the SIM card. So first one IFF's standard SIM card, and afterwards we go for one and then two, third and four nano SIM card. Now we basically we are using this nano SIM card is the development and evaluation of the SIM. So here central processing unit. So central processing unit is nothing but that is here the overview, the essential functions of the CPU. Here we have fetch the instruction. Fetch means we are retrieve the data from the memory. Okay, read and write the data from the memory, and interpret instructions, fetch the data, and process data, perform the arithmetic and logical operations or data movements, and via data store the result back to the memory or input or output devices. Here in the CPU components we have that is identify the architectural part of the CPU, control unit, arithmetic and logical unit, memory management unit, address generation unit, registers, and data register, address register, floating point register, and central purpose register. So first one is control of unit, is direct all the operations whatever we are doing under the processor, and arithmetic is perform the mathematical and mathematical operations using binary logic, and memory is translate the logical address into physical address memory. And here address generation unit calculate the address for the CPU to access the main memory. And register is nothing but is a memory location. It's a small memory location. In that data register means it to hold the data. Address register to hold the memory of the address. Floating point register store the decimal number. And general purpose register is versatile register for various uses. So the concept we have under the CPU, and here we have ARM architectures in mobile devices, that is advanced RIC machine is a specific architecture of CPU basics on RIC, that is reduced instruction set computers principle. So here the desktop PC is strictly used 86 processors designed for the heavy power consumption. Mobile phones require battery consequence, so utilize ARM RIC architecture by simplifying the instruction down to simple command executed quickly. The device preserve battery while saving. So here in this ARM V8 architecture, 64-bit utilize 64-bit address spaces, and 31 general purpose registers are the 32 instruction, and double precision for floating point supports, and hardware acceleration and for acceleration for computer. It is playing that important to enhance the security operation through faster processing. So cover this slide, this ARM architecture. This slide covers the architecture layout of the recent mobile chip like Apple's A series chip. The most significant feature for the forensic is hardware accelerated cryptography, because encryption is handled directly by dedicated optimized hardware. Cracking user passcodes or file layers cannot easily bypassed via basic software manipulation. So an important thing. And here the summary around this is that is CPU memory, that is role we saw. It acts as a brain of the device and performing the data processing, and key functions, how it's fetching registers, this concept, and components, that is control unit, arithmetic logical unit, memory management unit, and various type of the register we saw. And mobile CPU architecture we saw ARM and RIC architecture, and ARM V8A features, the 64-bit processing, numerous and general purpose register, and double precision floating point and cryptographic acceleration. So here in this video we saw about the basics of mobile hardware and components. So thank you. Next video let me see later. Thank you so much.